let's continue looking at the various types of numbers. One type of number is called the even number. Now, that number, or a few examples of even numbers. It starts with 2. You have 2, 4, 6, 8, 10, 12, 14, and so on and so forth. Basically, it's really an integer that is divisible by 2. You can divide it into 2 equal parts. So that's an even number. Say, for example, you have a scale and you have the 2 balance. Alright? You have these 2 balances here. If you have an even number, say 8, you can divide 8 into 4 and 4. When you put 4 and 4 here, could be 4 pounds or whatever weight you have, the sides would even out because you have equal weights on in each scale. It could be 10. When you have 10, you can put 5 on one side, 5 on the other side, and you have everything even out, right? So you could put 5 pounds weight in this one and 5 in this one, and you have an even scale. So basically, that's an even number. You can divide it into 2 equal parts by 2. So you have both sides even. You can think of it that way. Alright? When you divide it by 2, you have no remainder. What about the odd number now? It's an even number. What about the odd number? Let's talk a little about the odd number. With the odd number now, you cannot divide directly by 2 and get 2 equal parts or 2 equal sides. For example, if you talk about the odd number, examples of odd number would be 1, 3, 5, 7, 9, 11, 13, and so on. Alright? For example, if you take 7, if you try to divide it into 2 equal halves without any fraction, just integers you're dealing with, you wouldn't be able to do it. But you could have, say, 3 on one side and 4 on the other. If you put 3 pounds here and 4 pounds here, you would have the right hand side tilt downward because it's heavier. So you have an odd pound out. So it's not even. So these are odd numbers. Sometimes even numbers are given as having the form 2n, where n is an integer. So 2 times 1 is 2. 2 times 2 is 4. Right? 2 times 3 is 6. So you always end up with an even number. When you multiply any integer by 2, it's always an even number. And then a formula for you to get the odd number is 2n plus 1. Sometimes that's given. So in 2n plus 1, you have 2 times 1 plus 1. That's 2, and 2 and 1. That's 3. 2 by 2 plus 1 is 4 plus 1, which is 5. Suppose you have 2 by 0 plus 1. It's 0 plus 1, which is 1. So you have 1, 3, 5. 2 by 3 plus 1. That's 2, 3, 6, and 1, 7. 7, and so on. So this is a formula that gives you odd numbers, and this one gives you even number. Alright? So that's even and odd numbers. So now, just to make a note of the examples that we have here. With odd numbers, or let's start with even. With even numbers, you have 2, for, let me lengthen this out a bit, 6, 8, and you continue with that pattern. Alright, so those are even numbers. With the odd ones, examples of the set of odd numbers are using curly brackets because you use that when you're writing down a set of numbers or anything else. Let me just get rid of this. So right, okay, so examples of the odd numbers will be 1, 3, 5, 7, 9, and so forth. Good. Now, prime numbers. What about the prime numbers? The prime number, let me just get rid of this first and write down my prime number. With a prime number now, it's a number where if you try to divide it, you can divide it by itself and get 1. You can divide it by 1 and you get itself, right? Any number you divide by 1, you get back the same number as the answer. You divide a number by itself, you get back 1 as the answer. But if you try to divide it by any other number, you will not get an integer. You will get a fraction, a decimal, right? Those are prime numbers. So, with the prime number, one way to say what it is that it is divisible by 1 and itself only. No other number. Any other number you try to divide it by, you get a fraction, right? So, examples of prime numbers would be like, let me see now, you have 2. The thing is, 2 is an even number. But the argument is that 2 is the only prime number that is even, alright? You have 3, 5, 7, you have 11, you have 13, can you think of any more? 14, 15, 16, you have 17. And other prime numbers. There's an infinite number of prime numbers, right? So mathematicians are asking you to prove whether that is so or not. But I'm assuming that there's an infinite number of prime numbers, right? Now, when it comes to these type of numbers, sometimes you're given a certain number and asked, it could be in a multiple choice exam, you're asked whether such and such number is prime, or which of the following number is prime, or which of the following number is not prime. Sometimes you exercise some method of finding out if a number is a prime number or not. For example, if the number ends with 2, you know it's not a prime number. It's an even number. An even number ends with 2. If the number ends with 0, you can always divide that number by 5. Alright? It would be 1, 0, 2, 0, 3, 0. You can always divide that number by 5. Could be 15, can divide by 5. Not 15. I'm talking about 0. Right. Alright, so once it ends with 0, you can divide by 10. You can divide it by 5, by 2 as well. Alright? If the number ends with 5, it's divisible by 5. Could be 15, 25, 35, whatever number that ends with 5 is not a prime number. Another thing you can bear in mind if you're asked to show if a number is prime or not. If you have the digits, when you add the digits, if you get something that can be divided by 3, then that number is also divisible by 3. For example, 1, 5, 150 something. 15 is divisible by 3. 5 and 1 is 6, 7, 153. It is divisible by 3 because 1 and 5 is 6 plus 3, 9. You can divide this by 3. 3 into 15, 5, 3 into 3, 1. So those are just some things to bear in mind if you're going to be answering a question where you're asked to show which of the following number is prime or which of the following number is not prime, or whether or not the following number is prime. Alright, so those are prime numbers. Now, composite numbers. What are composite numbers? Well, it's really those numbers that are not prime numbers. Alright? You can divide those numbers by other numbers without leaving a remainder. One thing you can say about the composite numbers is that, for example, if you have 2 times 5, that gives you 10. If you can divide this by 2, it means it is composed of 2 and another number multiplied. This is composed of 2 and 5 multiplied. It's a composite number. That's one way you can remember it. So once it's not a prime number, it's a composite number. Suppose you have 3 times 7. That gives you 21. You can divide 21 by 3. You can divide 21 by 7. It's composed of 3 and 7 multiplied together. So the composite number is a number that is not a prime number. So you basically have 2 types of integers. Numbers that are integers. They are prime numbers and composite numbers. Then we have the square numbers. Alright? Suppose, for example, when dealing with square numbers, let me just make some space here. Suppose you look at a set of numbers where you square other numbers to get it. 1 squared is 1. 2 squared, 3 squared, 4 squared, 5 squared. So 1 squared is 1. 2 squared is 4. 3 squared, 3 is 9, 4 4 16, 5 5 25. Those they consider as square numbers. So basically, you can form a square with the side measure 1 and 1. You can form a square with the sides measure 2 and 2, and the area is 4. Alright? You can form a square where the sides measure 3 and 3, such that the area is 9, and so on and so forth. So 9 is a square number. You can actually find the square root of 9 to be an integer, which is 3. So you can consider 9 then as a square number. With 16, can you find the square root and get an integer? Yes, it is 4. So in this case, 16 is a square number. 16 is a square number because you can get it by squaring another number, which is an integer, which is 4. Same thing applies to 25, and so on and so forth. Those are square numbers. Alright, so that will be it for now on these types of numbers. We'll continue with this topic at a later date.